Rahim. I'm honored and glad to be here in Egypt, especially I was a graduate of Ain Shams University some time ago. أشكر الأستاذ الدكتور عادل عبد العزيز وزملائه الدكتور مصباح كامل والدكتور خالد حبيبي for giving me this opportunity. I was assigned the duty of talking about adipose tissue. As you see, this is the title of my talk. And I start by saying that there are two types of adipose tissue. One of them, the most common, is the white adipose tissue. As you see, the cells are a scattering of cytoplasm surrounding a single large lipid droplet. And the nuclei are flattened and eccentric within the cell, and the size 25 to 150 micrometers. The major role in glucose, fatty acid, lipoprotein, and cholesterol metabolism. And there are two sites of distribution, mainly the internal or visceral adipose tissue and subcutaneous deposition. The brown adipocytes, on the other hand, are polygonal in shape, have a considerable volume of cytoplasm, contain multiple lipid droplets of varying size. The nuclei are round and almost centrally located, 15 to 25 micrometers, and is involved in thermogenesis. Brown adipose tissue is most prominent in newborn animals and in hibernating mammals. In human infants, it comprises up to 5% of body weight, then diminishes with age to virtually disappear by adulthood. However, by recent advances in technology, including the PET-CT scanning, there is a considerable amount of brown tissue has been shown, and especially in the upper part of the body, even in adults. In contrast to the other cells, including white adipocytes, brown adipocytes express mitochondrial uncoupling protein, which gives the cells mitochondria the ability to uncouple oxidative phosphorylation and utilize substrates to generate heat rather than ATP. And that's the importance of having brown adipose tissue in infants and hibernating animals which cannot shiver to generate heat. Now we focus on the adipocyte. As you see, the triglycerides are stored fat droplet. Lipoprotein lipase acts on the chylomicrons and very low density lipoproteins to form free fatty acids which pass into the cell. And lipogenesis from blood glucose is minor. The free fatty acids are also found down to albumin. They go inside the cell, and in the cell triglycerides are formed for storage. The fat cell is not only a fat storage cell, but is a metabolically active secretory cell, producing a large number of proteins, hormones, cytokines, and growth factors. This is a list of the substances that are secreted or produced by the fat cell. Cytokines and cytokine-related proteins, including leptin, tuber necrosis factor alpha, interleukin 6, the immune-related proteins like MCP1, proteins involved in the fibrinolytic system, PI1, and the tissue factors. Those that belong to the complement-related proteins, adipsin, complement factor B, ASP, and adiponectin. Those that are related to lipid and proteins for lipid metabolism or transport, you see. and enzymes involved in steroid metabolism, cytochrome P450, dependent aromatase, 17 beta hydroxysteroid dehydrogenase, and 11 beta hydroxysteroid dehydrogenase, and AGT and AGT resistine. And not only substances, there are also receptors for traditional endocrine hormones present on the fat cells, like insulin receptor, glucagon, growth hormone, gastrin, glucagon like type 1 receptor, and angiotensin 2 receptors, type 1 and 2. Nuclear hormone receptors for glucocorticoid, vitamin D, thyroid hormone, androgen, estrogen, and progesterone receptors are present. And cytokine receptors for leptin and TNF-alpha, and catecholamine receptors. Some of the functions of these substances that the fat cell, the adipose tissue is producing. And we here try to move to another aspect of the adipose tissue, and that is how obesity is produced. So this slide shows the gut peptides that regulate appetite. You see the GI tract on the left-hand side of the slide. Ghrelin and gastrin are produced by the stomach. Insulin and glucagon, pancreatic polypeptide, and amylin are produced by the pancreas. GLP-1, GLP-2, oxyntomodulin, and PYY are produced by the GI tract, and each one of these has its function. In addition to cholecystokinin, secretin, GIP, and motilin. On the right-hand side of the slide, you see how these peptides send signals to the brain to affect satiety and hunger. Ghrelin is one of those hormones which is produced by the stomach. It signals hunger, and this slide shows you that at the time of breakfast and lunch and dinner, there is a surge of ghrelin. Leptin is somewhat more, has special importance. As you see, in 1953, Kennedy proposed body energy stores were regulated by fat-derived lipostatic negative feedback signal acting centrally to inhibit feeding. And in 1994, leptin was identified. Not going to read all this, but it has a lot of functions, as you see, and the primary functions may be unrelated to satiety, but it is an important factor for satiety. As you see here, it has also many other functions. This model summarizes the three levels of control over energy homeostasis. The first is this, the signals that come from the GI tract to the hypothalamus, to the substances that we talked about, and from the fat tissue. This is the second level, through leptin and insulin to the hypothalamus. And the third level in the hypothalamus, where assimilation or integration of all these inputs that reach the hypothalamus to produce a sense of satiety or hunger. And this model of the arcuate nucleus, which is the main site in the hypothalamus that receives these signals, this model shows the afferent signals from the periphery that modulate the activity of hypothalamic neurons in a reciprocal way to increase or decrease food intake. Leptin is an important, or the ultimate messenger of fat stores. In case of congenital leptin deficiency, this is an extremely rare situation, and this was successfully treated with leptin. And this is here at 3 years of age, the weight was 42, the body weight, 42 kgs, and at age 7 years, the weight was 32 kgs after treatment. Peptides that affect food intake, as you see on the left-hand side, those that increase food intake or appetite, and on the left-hand side, the ones that decrease food intake or reduce satiety. And so what is causing the epidemic of obesity, and why is it so hard to lose weight? This is a complex slide, as you see. So I'm not going to be able to explain it. It will take too much time. And this is a summary of the hypothetical feedback, feed-forward positive feedback mechanism which drives weight up. The high-fat, high-carb food will lead to hypothalamic injury, which has been demonstrated, leading to POMC neuron dropout and leptin resistance. This will lead in turn to that the brain cannot tell how much fat is stored, and so increases fat mass to restore equilibrium. This will lead to reduced sense of satiety and craving, and with the metabolic effects of that. That will lead also to increased food intake and weight gain, increased hypothalamic injury by this increased weight, and increased leptin resistance. That will complete the cycle, the vicious cycle. The endocrine changes associated with obesity, on the right-hand side, those that found to be increased, you can go through them. And on the left-hand side, those that are decreased, growth hormone, ghrelin, and adipocyte. Do genetics have any influence on body weight? There is evidence of that. These are identical twins. And this is a study of dizygotic and monozygotic twins. You see that on the left-hand side, the monozygotic twins have more concordance for obesity, while dizygotic twins do not have that concordance. And if the parents are, if there is, the childhood obesity will lead to adult obesity. If there is no parent obese, you see here, neither parent is obese, there will be 24% chance, while if there is at least one parent obese, it will be 62, the chance for adult obesity. And at the age of 10 to 14 years, these are the numbers. In the last 30 years, over 250 genes have been identified that appear to affect risk for obesity. However, our genes haven't changed in the last 3 decades as obesity rates have risen dramatically. Thus, environmental factors appear to play an important role in the obesity epidemic that we are witnessing. You have heard of the thrifty gene hypothesis that was circulating for quite some time. The hunter-gatherer, they feast and also to guard against famines. They have maximum metabolic efficiency, leading to survival at the end. In modern society, we eat and feast most of the time. The diet is rich in animal fat and sucrose. With sedentary lifestyle, visceral obesity, this will lead to insulin resistance and beta cell exhaustion, leading to diabetes. Famines do occur, and this slide shows the famine that occurred in Damascus in 1918, Sefer Berlin, Unfortunately, this is repeated again nowadays 100 years later, especially in certain parts of Syria, the northern part in particular. Now this is what we have. The visceral and the anaerobic obesity. The difference between them, the visceral obesity is the one that's more dangerous, as you know. Why is this? Western lifestyle, less exercise, number of hours watching television, Coca colonization and McDonaldization. You see that a quarter pounder cheeseburger with a large fries and a 16-ounce soda will provide 1,166 calories, 51 gram fat, 95 milligram cholesterol, and 1.5 grams of sodium. Obesity is associated with adverse outcomes in adults. I'm sure you are aware of many of these. The list is long, and also of course, associated with increased risk of cancer. The medical complication is a photographic, descriptive representation of what I said. The prevalence of obesity is high, as you see here in Europe, USA, and Australia. The highest is in the USA, both in black and white. In black it's more. And in Australia, it's in Aborigines, the original indigenous population of Australia, it's higher too. And women in the developing world, here we are. And in the States, it's on the rise from the 1990 to 1998 and to 2006. And it's projected that by the year 2040, 100% of Americans will be overweight, and by the year 2100, 100% of Americans will be obese if this trend is not brought or is not checked. Hippocrates once said, obese people should perform hard work, eat only once a day, take no baths, sleep on a hard bed, and walk naked as long as possible. And here is, after 2 years in the USA, Michelangelo's David is returning to Italy. This is before, and this is after. Thank you.